Hello everyone, this is Cornerstones of Math and welcome to my video. In this differential calculus problem, we are going to differentiate the function that satisfies certain conditions. And without further ado, let's take a look at the problem right now. So it says a twice differentiable function fx satisfies the following relation. Fx plus f of fx equals x for all real number x, and the value of f0 equals 0. Then what are the values of f prime 0, the first derivative, and f double prime 0, the second derivative? So obviously, in order to find f prime 0, we must differentiate the given equation. Here you have to appropriately apply the chain rule, which is the derivative of g of fx is given as g prime fx times f prime x. So basically, we have to differentiate this inner part fx and multiply it. Okay, now let's differentiate this. Then we have f prime x plus, now we have to differentiate this part. So first we have f prime fx, then we have to differentiate this fx, so we have f prime x. And on the right hand side, if we differentiate x, we obtain 1. Letting x equal 0, we have f prime 0 plus f prime f0 times f prime 0 equals 1. Here we use the given condition that f0 equals 0, so this part right here is 0, so we have f prime 0 plus f prime 0 times f prime 0 equals 1. So this part becomes f prime 0 square, then we have f prime 0 minus 1 equals 0. And if we use the quadratic formula, we obtain f prime 0 as minus 1 plus minus square root of 1 square plus 4 over 2. So we have minus 1 plus minus square root of 5 over 2. Now let us find the second derivative. Here we have to start from here. So let's actually rewrite it down there. Now we have to differentiate both sides again. But here, in the second term of left-hand side, there is now a product of the two functions. So here we have to apply this product rule, which is also the very famous property of the derivative. So let's consider this part as u and this part as v and differentiate. Then we have f double prime x plus, we have to differentiate u first. So we have f double prime fx, then we have to differentiate this fx. So we have f prime x. So this right here is u prime. Then we have v, which is f prime x. Then we have u v prime part. So we have f prime fx, which is u, and then v prime, which is f double prime x. On the right hand side, if we differentiate constant 1, we obtain simply 0. So we have f double prime x plus f double prime fx, and this part right here gives f prime x square plus f prime fx f double prime x equals 0. Letting x equal 0 again, we have this. And then again, we use the given condition that f0 equals 0. So we have this equation. Now notice that we have this f double prime 0 as common. So we can write f double prime 0 times, we have this part, f prime 0 square plus this part, f prime 0, then 1 here. So we have plus 1 equals 0. So here, either this can be 0 or this can be 0. However, we have already obtained that f prime 0 is minus 1 plus minus square root of 5 over 2, or more useful expression is from here, which gives f prime 0 square plus f prime 0 equals 1. Using this, we can handle two different values of f prime 0 at the same time. Therefore, from here, this part, f prime 0 square plus f prime 0 plus 1 equals 1 plus 1, which is 2, which is obviously non-zero. Therefore, this part cannot be 0. Therefore, for either case, regardless of the value of the first derivative, we have f double prime 0 equals 0 from here. And that was all for this video. Thank you for watching, and I will see you in another video.